and we have finally made it to astronomy. So with astronomy, we're going to first begin by talking about our solar system. So what is the solar system? The solar system is the sun and everything that orbits around the sun. So this is going to include the sun, planets, comets, asteroids, moons, all that other stuff. Okay, the definition of the solar system being the sun and everything that orbits around it is more inclusive and easier to say than listing all of the different pieces that are actually in it. As we look at planets, we can actually split them into two categories. There are the inner planets and the outer planets. So the inner planets are Mercury, Venus, Earth, and Mars. The outer planets are Jupiter, Saturn, Uranus, and Neptune. The four inner planets are also known as the terrestrial planets. Terrestrial means Earth-like. So these planets have a solid surface and are made of rock and metal, similar to what we've talked about previously with the Earth. The outer planets are also known as the Jovian planets. Jovian means Jupiter-like, so these are sometimes referred to as the gas giants. Now, how did the solar system actually form? The current idea is known as the nebular theory. This suggests that the sun and the planets, the entire solar system, actually formed from a nebula. A nebula is a giant cloud of gas and dust in space. So if you remember back when talking about gravity, we mentioned that gravity acts on mass and is always attractive. Gravity always pulls matter together. So we start out with a giant cloud of gas and dust, specifically a very large nebula. This type of nebula is sometimes referred to as a dark nebula because it does not give off its own light and in fact is cold enough that it absorbs the light that hits it. Inside of this dark nebula, there'll be small pockets that have enough density where gravity is high enough and pressure is low enough that they'll begin to collapse under their own weight, that gravity will actually cause them to pull together. Now, as these things are collapsing, if you remember way back when we talked about conservation of momentum, we also talked about conservation of angular momentum. As things that are rotating pull in, they rotate faster. The classic example is of a figure skater. If you can imagine a figure skater with her arms out wide, when she first starts spinning, she's going slowly. But as she draws her arms in close, then she speeds up. The same thing is going to happen within the disk. As the entire cloud, pocket within the cloud is collapsing, in the direction that is rotating, it's going to rotate faster and faster. What this means is it actually causes the cloud to fall into a disk shape. Now, most of the material will end up at the center, but we're also going to have a disk of material surrounding that center region. The center area that has the most material and will also be the hottest is going to be the protosun. Surrounding the protosun we have the protoplanetesimal or the protoplanetary disk. So out in the disk, we're going to have the right conditions for materials to turn into a solid. So at first, near this protosun where it's warm, only materials that can form at high temperature, so rock and metal, are able to form. Farther away from the center, it's going to get colder and colder and colder, so out in the edges of the disk, it is going to be cold enough that ices are going to be able to form. So in the inner solar system, all we get are rock and metal forming. In the outer solar system, we get rock, metal, and ices. Now these particles are going to start clumping together, forming larger and larger. This process of them clumping and getting larger is the process of accretion. So we start out with a whole bunch of different kinds of flakes all throughout the solar system that begin to clump together, growing larger and larger. Over time, they will eventually become big enough that they'll have enough gravity that gravity will be able to start pulling them together, speeding up the process. And this is going to continue until eventually we're left with just a few planets that are on relatively stable orbits around the sun. So the planets formed through condensation and accretion within the protoplanetary disk that surrounded the protosun. Here is our first question for today. As a nebula shrinks under the influence of gravity, it A. spins slower, B. spins faster, C. loses its spin, or D. spins into a protosun. Go ahead and think about it and we'll discuss in just a bit. All right, now that you've had a chance to think about it, the correct answer is B. It spins faster. And so this is because of conservation of angular momentum. So as the whole thing shrinks, the rest of the material has to spin faster to make sure that angular momentum is conserved.